In this video, I'm going to show you how to build a melee enemy AI that comes equipped with a patrol mode that is sensitive to platforms and walls, a combat mode with 2 kinds of attacks, and a defense mode that requires just a little bit of strategy to overcome for a kill that is made entirely with Unity and bold visual scripting. Let's begin.
Shall we play a game?
Welcome, ladies and gentlemen, to part 1 of my complete 2D enemy AI series that is made entirely with Unity and bold visual scripting. Since starting my YouTube channel last year, a tutorial on enemy AI has been one of the most popular requests I've received, so I thought I'd take a little break from my top-down 2D Zelda-like RPG devlog and bring this video to you. And as usual, I have a few disclaimers before we begin. First, while it's not entirely necessary, if I were you, I would first go back and finish my complete 2D player controller series before you attempt this build, since there are several macros that we're going to pull from that series. It is possible to complete this build without doing so, but you're going to want some kind of player controller to be able to completely test things out like damage and attacks. So proceed only when you're ready. Second, if you're the kind of person that prefers a written tutorial to the video format, you can find a link on my Patreon page that will show you how to do this project, and it has written out instructions as well as pictures, which is free for everyone to use, so be sure to check that out if you're interested. And third, I realize this video is much longer than my usual tutorials, but I figured you would just rather have one long video than have multiple videos spaced out over the course of several weeks. And of course, here comes my shameless plug. If you'd like some tech support on this build, I'm only going to be responding to questions that are asked in my private Discord server that can be accessed by becoming a supporter on Patreon. This video is going to show you how to complete the melee enemy section of my complete enemy AI series, which means by the end of this video, you will have that melee enemy that's shown in the intro. But if you'd like to know how to make the projectile firing enemy, for example, or the enemy that flies through the air, I've reserved those 2 tutorials for my second tier patrons and up. For all of my top supporters, I've made it possible for you to skip hours of tutorial content and download the before and or after project files for each completed step in the series. With that out of the way, let's get started with this build. For this build, we're going to use the Monster Creatures Fantasy Pack that you can get off the Unity Asset Store. It's put out by Luiz, Melo. He's got a ton of stuff, and this guy is really, really good. Really like this guy. You can get this, again, on the Unity Asset Store. I'll put a link in the description below. You'll notice that this is the skeleton that we're going to use for part 1, and we're actually going to use that flying eye right there for part 3. So if you want to go ahead and add that to your assets, I'll show you how to get that into your Unity build. Once you completed my complete 2D player controller, you should have something that looks like this, or if you're one of my top supporters, you will have this file. To import those sprites into your game, if you're going to use the Unity Asset Store approach, you can go to Window, go to Package Manager, and under My Assets, you should see here Monster Creatures Fantasy. You just import that. You're going to have to download it first, but import it into your game, and you will get some sprites. Now, I went ahead and I'm a little bit more organized probably than the average bear here. Assets, Player Controller Sprites, Enemy, and here's my skeleton folder. I would recommend putting them all under here. And you should have something that looks like this. And what you're going to want to do is you're going to want to go ahead and select all of them, and then we're going to set the sprite mode to multiple. I set my pixels per unit to 35. That actually matches pretty well what I have for my player here. And set it to point no filter. You're going to put the compression to none and hit apply here, and it will go ahead and get your sprites ready. Now you're also going to want to go one by one, go to the sprite editor here, and you're going to have to hit slice here, and we're going to do grid by cell size, and I believe the size on these is 150 by 150, and you should notice that it will slice these sprites up perfectly here, frame by frame by frame. This is the attack 1, and you're going to need to do that for all of your sprites. So once again, go to attack 2, hit sprite editor, slice. Now the settings should already be in there. Hit slice and apply. Go ahead and do that for all of your sprites and pick this up when you're done. Okay, once you get all those sliced up and ready to go, you should have something that looks like this. They're all in different sprites now. And what I'd recommend doing now is going to idle, grabbing idle 0, and just kind of dragging him on the scene. Now, if you'll notice here, when you put him down, he'll stand behind stuff instead of in front of it. And the way that we're going to fix that is when you drop him, you're going to go over here to the sprite renderer, and the sorting layer, we're going to set it to player. Now, if you took my 2D player controller series, then this should already be set up. You should already know how to do that. If you don't know how to do it, go back and watch that series. So now he should be rendering in front of all of these things. We're going to go ahead and rename our skeleton here, our idle 0 to skeleton. And now what we're going to do is we're going to go to the animation tab. Now, if you don't have the animation tab visible here, you can go to Window, go to Animation, and then right here you're going to click Animation, and it'll bring up this animation window. And it says to begin animating skeleton, create an animator and an animation clip. So what we're going to do is here we're going to hit Create, and I do not want it to put it inside of my sprites folder because I am super OCD about where my stuff is going. I created a new folder here, and this is from the player controller, and I have a new folder here called enemy, and these are all the old ones, so I'm going to delete all of these, and we're going to get rid of those, get rid of that, get rid of that, get rid of that. Don't want that. We're going to completely start over, and let's just do one called actually, let's create a new folder first, and let's call it skeleton. And then as we open that up, let's do one called idle and just hit enter. Now we should have something that looks like this. And before we actually start dragging in things and working on those frames, let's go ahead and create the rest of our animation clips. So we have idle. Let's go ahead and do attack 1, and then do it again. Attack 2. Let's do create a new clip. We're going to do death. We're going to do shield. We're going to do hurt instead of take hit because I just like hurt better. Hurt, and then we're going to do walk. Okay, now as we set up these animations, you're going to want to select each one of them individually. So let's go to idle first, and let's drag in all of the idols right here, and then we're going to set the frame to or the samples to 10 frames per second here. Actually, I don't think is that right? 10 frames per second. I think that's right. Yeah, so if you notice here, when it was at 60, if you watch the little skeleton over here, so if we set it back to 60, you notice he goes a lot faster. We want him to go a little bit slower than that, so we're going to set the samples to 10. Go ahead and set up all of your animations one by one by selecting those and setting the frame rates to 10. Okay, once you get all of those animations set up, you should see that they will go ahead and play over here in not only your scene view, but also in your game view as you hit play. All of them are already set up. Of course, hurt is the take hit. Just keep that in mind. All of the samples are set to 10. And you'll notice that they also will repeat, and that's just the nature of the animator here. Outside of play mode, but we actually don't want them to loop at all. Several of them we don't want to loop. Now all I've done here is I have arranged this as they came out. I don't know, I like to be organized. Idle, we know idle and walk are going to be looping, but animations like shield, so we're going to double click the shield, we're going to take off the loop time on that one. Attack 1 is not going to be a loop. Attack 2 is not going to be a loop. Hurt is not going to be a loop. Meaning that it's not going to sit there and play over and over and over again. And, of course, death is not going to be a loop. Now, since creating my 2D player controller, I've learned a few things about Unity and animating and doing things for 2D games. And this right here, I'm pleased to announce that this is the completed animator. You will no longer have to mess with the animator ever, ever, ever again. Which means that I can successfully show you a way to escape animator hell. If you don't know what animator hell is, let me show you what animator hell is. This is animator hell, and believe it or not, this is still very, very organized. As you come in here, you see all these little arrows and spider web of deceit here. This is terrible. Do not do it this way. If I could ever go back and fix that, I would. Maybe I will one day, I don't know. But this is the completed animator controller. I'm going to show you how to do all of this through code. So we're not going to use the animator. We are going to trigger those animations through code, and I'm going to show you how. Okay, the next thing that we're going to want to do is we're going to go to our skeleton game object and we're going to add some components. So let's start with a capsule collider 2D. You're going to notice that it will give you a circle little collider here. We're actually going to squeeze that down a little bit. So if you set the size on the X to 0.5 and the Y to a 1.5, I believe, you get something a little bit more reasonable here. Of course, the direction needs to be set to vertical. We're also going to want to add a rigid body 2D, and under this you're going to set the collision detection to continuous so that we'll always be checking if it's running into something, and we're also going to want to come under constraints right here, and you will freeze the Z rotation. That will make sure that it doesn't flip one way or the other. And of course, the next thing we're going to do is we're going to add a state machine. We're not going to add a flow machine, we're going to add a state machine. And the reason why is because this will have several states that it will move from. So idle to attack to death, all of that jazz. So what we're going to do is go here, go to new, and I like having my macros under player controller macros, and I'm just going to create a new folder here. We're going to call this enemies. And then we're going to double click that and then create another folder called skeleton, and we're going to place the skeleton. So type in skeleton here, and this is going to be our state machine that we are going to build. And once you get that put on your game object, it should look something like this. Rather than taking time out from our build as we're making these macros, go ahead and make all of these object variables now. I'll go ahead and explain them as you're making them. So you're going to need one called health, and the way that you type these in where it says new variable name, just type in the name of the variable and hit the plus sign, and then you're going to get a little drop down here to where you can select what you want each one of these to be. So let me go ahead and show you all of these variables. Go ahead and add each of these in, and then as we implement the code we will be using them. Let me go ahead and explain what they are. Of course, health is the enemy's health. It has 3 points of health. Then you have speed and chase speed, which are both floats. Speed is going to be how fast the player, or excuse me, the enemy moves outside of combat. Chase speed is how fast he moves inside of combat when he's chasing the player. Then we have attack damage, which is pretty obvious, how much damage he does when he attacks, how many units does he hurt the player for. And again, you can set these numbers to anything that you want, but as we get to things like attack int, you're going to leave that one alone. But you can experiment with some of these. Attack CD or attack cooldown is how often he can swing his attack. That's going to be a float, and set that to 1. And then of course we have vulner time. So he's going to be blocking, and after he swings is whenever you actually can hit this skeleton. So how long is he going to be able to be attacked? So vulner time is going to be set to a float of 1 second. You can increase that or decrease that to your preference. Then of course you have attack radius, how big the attack is going to be in an area. Then you have attack int. You're going to want to leave this at 0. The reason we're using this is to determine whether he's going to have 2 attacks. Is he going to swing with the first attack or the second attack? That's what that's going to be used for. Of course, X you're going to want to leave alone as well. That's going to be a float set to 0. This is going to be the direction he is going. It's going to either be a positive 1 or a negative 1, but go ahead and leave it at 0 right now. We'll go ahead and set that with code. Of course, you'll have aggro range, which is a float of 4. The aggro range is exactly what it sounds like. How far away can the player be before this skeleton enemy AI will go into combat mode and aggro? And of course, leave aggro, I have that set to 7. That's how far the player has to be away from the skeleton for it to go back to normal. And then I have pushback, which is a float of 3. Now what this is doing is whenever the player attacks the enemy, it's going to slightly slide him back. So that's what that pushback is. You can increase or decrease that one. Then of course all these booleans you're going to want to leave how I have them set. So a combat, a boolean, this is whether or not the enemy is in combat. It's either true or false. Whether he can attack or not. Whether he's blocked to the right or blocked to the left. Whether the enemy is dead. Now the reason you have that is so that it doesn't do anything else while he's dead. We're going to go ahead and set that up in the code as well. Then you have in range, which is in range of the player to attack. Then we have block, which is also set to true here. Can attack and block are set to true, so that the enemy is going to start off by default as blocking. And then, of course, we have an idle phase. So is the enemy idle? And, of course, we want that for the way that we have our code set up. So go ahead and get all of these object variables set up one at a time, and when you're done, we'll continue. Okay, I meant to mention that when you're putting those object variables in, make sure that you check the spelling, because if any of that is wrong, just make sure it's case sensitive too. Just go ahead and just double check everything and make sure it's right. Now, once you get that all set up, we're going to go ahead and set up our state machine here. This is the overview state machine, and for the rest of our time together, we're going to be going into each one of these and putting in the necessary units. So go ahead and with the start one here, you're going to rename that state handler. So state space handler here, and then we're going to need to add a super state here. This super state is going to be non-combat, so non-combat, and then we're going to need one for combat, so create another super state here, and let's call that one combat. And then we're going to go right over here, and we're going to call this one, so we need a flow state, not a super state, but a flow state. I'll show you the difference in just a second. This one is going to be hurt. Then we're going to need a dead flow state, so dead, and then we're going to need one more for blocking. So go ahead and put in the block right here. Now we're also going to need transitions between these, and one of these needs to start as we start the game. So the way that we're going to do that, let's go ahead and put our transitions in first. So right-click on non-combat, make a transition here from non-combat. You see this little arrow that goes to combat, and then send another one back. So make another transition and come right there. Now we're also going to need one from non-combat to hurt, and we're going to need one from combat to hurt. So make a transition there, and then we're going to need one from hurt back to combat. And the reason we're not going back to non-combat is if we ever hurt the skeleton, we want him to immediately enter in combat mode if for some reason he's not, which he always will be. But if for some reason he's not, we want it to come back to combat. And then, of course, if it's hurt, we need to move from hurt to death. And then from our hurt, we also want to make a transition to our block. So it's going to be blockable or it's going to be hurtable. So, and then from our block, we're going to come back to combat here. Now, we're also going to need to do one more little thing here, and that is to set our non-combat mode as something that is going to start. When we trigger start, we need him to start in non-combat mode. So just go ahead and right-click your non-combat mode, and then hit toggle start, and you should notice that it turns green. The rest of these are going to be just set to default here, and we're going to spend the rest of our time together setting up all of these macros. I probably should have explained one more thing. You might be wondering, why is non-combat started and state handler started as well? Why do we have this one as a toggle start? The reason why is because this one is going to be running all the time, and this is what's going to be pretty much switching between all of our states. So as we hit play and later on down the road, you'll see this, that it'll move from non-combat to hurt to back to combat, or from block to hurt, or vice versa. Like this state handler is going to be handling that. So now let's go ahead and set up our non-combat mode. Let's go ahead and get this one all fixed up. So what we're going to do first and foremost here is we're going to rename this start right here. We're going to name that idle. So go ahead and just click right up there and do idle, and then we need another super state machine right here, and we're going to call this one walk. Now, of course, this one is going to make a transition to this one, and this one is going to make a transition, whoops, not toggle start, we're going to make a transition back to idle. And as we open up our walk state, we're also going to need several states inside of this one as well. Now, this one is going to be renamed to enter. So as we enter state, whoa, what did I do? Oh, I messed that one up. So go back here, do walk. Is that right? Yeah. So walk, and then as we come into start here, we will rename this one enter. Then let's make two more flow states, and I'll explain what these are doing here in just a second. Let's name this one left, and let's name this flow state right. Now we are going to also make a transition from enter to left, and one more transition from enter to right there. Okay, once you get all that set up, go back to the skeleton state machine here. We're going to enter non-combat, and then we're going to go in to set up the idle first. So what we need to happen whenever the enemy enters this idle phase is we needed, of course, to play the idle animation. Now remember, I told you we're going to escape animator hell once and for all. We're never going to use that again. This is how we're going to do that. Go ahead and delete these 2 units. You're not going to need that. But go ahead from our on enter state and hit a play animator, or is animator play? Animator play, and we need state name. And now this is the animation that we are going to play. So we're going to say play the idle animation, which is that one right there, and should look just like that. So we're going to on enter state, which this one is starting, by the way. So this one is starting, and this one is starting right here. So idle, this is the first thing that's going to happen. It's going to play that idle animation. Now we also need it to trigger a decision to walk. So the way we're going to do that is we're going to come over here. We're going to say timer, and we're going to set a timer on that. So we want it to start a timer, and the duration that we're going to use is actually going to be a random interval between 1 and 3 seconds. So the way we're going to do that is drag our little duration node down here, and then we're going to go to a random range. Now, the difference between these 2 random ranges, you might wonder, one is a float, the other is an integer, meaning that this is going to be even decimal numbers, which is what we're going to use here. The other one is going to be whole numbers. So we say wait 1 to 3 whole seconds, or wait anywhere between 1 to 3 seconds. That's what we want. We don't want to be so specific. We don't really care. But maybe you want it to be specific. You'll use an integer instead of a float. So we're going to say wait 1 to 3 seconds, and then after you are completed from that, we're going to trigger a custom event. Now the custom event is going to be called walk. Okay, so and just for the sake of being organized, I don't know why I like to color coordinate my stuff, and the colors don't make any sense to, I can't explain them. That's just the way I do it. So this one's going to be play animation. By the way, I drag control as I do that. You can drag it or let it go, and when you drag it and let go, it makes a little grouping there. So this one is going to be play animation. This one's going to be purple. Set that one. That's all my animations are purple for some reason. Don't ask me why again. And then here we're going to do a trigger, or let's say delay transition to walk. And anytime in my code I like to do something, if it's carrying something out, it's starting something, then I like to do green there. So the reason you do that, just color coordination, is if you're looking at a big graph, sometimes you want to like, I need to go find an animator component. Okay, it's purple, so it's just easier to see. That's why you would run it like that. Now we are actually going to need to go up one level here. So after 1 to 3 seconds here, it's going to trigger a walk custom event, and this is where we're going to put that. So we're going to go from this idle to a transition to walk. So we're going to do a custom event here, and we're going to say from 1 to 3 seconds it's going to trigger this walk, and this walk now is going to go into the walk state. Now before we connect that, I just want to show you something real quick. When we come into the walk, all of this is considered walk. Now you have a walk left or walk right, and this interstate is going to be deciding between the two. So in order to play the walk animation, it's not necessary to do it here under enter. I'm actually going to do that right here from idle to walk, because I know that everything in my walk phase is going to be walking. So what I'm going to do here is I'm going to do my play animator. Gotta get backwards. Animator play state name, and then I had that animation set up under walk, I believe. Yeah, walk. So that's where we're going to do that right there, and we're going to trigger this transition. And again, I just like being organized. It's not necessary really, because here it's only going to be these 3 nodes. Animator, play animation. How about that? And then purple. Whatever. Leave me alone. I'm organized. Okay, once we get that completed, go into the walk super state there, and we're going to enter into the enter state. And here we are just going to need the enter state. So go ahead and delete the update and the on state enter. And here we are actually going to do something very similar. What we need to happen is we need it to randomly decide to go left or go right. And again, the way we're going to do that is we're going to use a random range. So go ahead, and this time we're going to choose the integer, because we want it to do either left or right. And so it's going to pick a random number between 0 and 2, so it's either going to pick 1 or 2. And now we're going to come over here to a branch. So we're going to ask a true or false statement. So is this number that it picked greater or equal to 1? Now it's either going to pick something less than 1, or it's going to pick something 1 or more than 1, right? So this is going to decide if it's going to go left or right. And the way that we're going to do that is very simple. Just come up here to a custom event, and then we're going to say right. And again, I like to be organized, so let's do walk right. And we're going to call that one green because it's going somewhere. I don't know, dude. It doesn't make any sense, I know, but it's helpful for me. So that's all you got to do is find something that's helpful for you. So left or right. Now it doesn't matter which way you put this because it's either going to be one or the other. It's just like a 50-50 chance which way is it going. And let's do that. Make it all the way green. There we go. And then this is going to be kind of a check. So any check that I do, I make it yellow, and I do random decision here, and gonna make that yellow. Okay, once we get that worked out, it's going to decide if it's going left or right, and we need to tell it to go left or right. So here we're going to make a custom event inside of that transition, and we're going to call this one left because this one is going to left, as you see right here. Whoops. I went in the wrong thing here. It's going to left, and then we need another one that's going to right. So custom event, and we're going to do right. And there you go, right into there. So now it's either going to go left or it's going to go right. Okay, once we get all that ready to go, we are now going to enter in our left state here, and we are going to need these two nodes. We're not going to need the on exit state. So let's start with the update here. And what I'm going to do on this one is I'm actually going to use a unit that I have created in my Complete 2D player controller. It's called Move Variable Transform. I had all three of those there, force, velocity, and transform here. But if you've never seen this before, this is how you make this. Basically, you'll start with an input node, and as you put in these variables right over here, it will let you set the nodes that are coming in. So you have a flow input called input, and then one called multiplier, which is a float. It has default values so that you can actually edit that outside the graph. So that has default value, has to be checked, and of course we have speed here. And I'm not going to bother explaining this because I explained this many times in my player controller, but basically we're going to be moving this unit the same way. And for our multiplier here, we're actually going to use our getX value, object variable that we set up. Now remember that was set at 0 originally, but we are going to be sitting that and determining which way it's going to go here in just a second. And for speed here, we are going to use the get speed variable. So we have x and speed going into this move variable transform, and this right here is going to be our move function. So I'm just going to tell that one is move, and I'm going to select green because it's completing something. And then we are also going to need a delay to go back into the idle state. So we have the idle state coming into a move, and then we want it to move a little bit for a little while and then stop. So basically we're going to do the exact same thing that we set up in the other one. So we're going to create a timer, and then we are going to use that same principle, the random range, and between 1 and 3 seconds. It's going to walk for 1 to 3 seconds, and then it is going to trigger a custom event called idle. So it's going to go right back into idle form right there. So we're going to wait the delay, and then, oops, spell that correctly, delay, transition to idle. All right, after that's completed, then we are ready for our right side. So the left side, just copy this and paste it into the right side here. Now you may be wondering, why are we using two separate flow states here? You know, we had a super unit here that we're going to use multiple times. Why did we have a left and a right if it's doing exactly the same thing? Well, because right at this moment it's doing the same thing, but as we continue building this code, they will be different. So the last thing that we need to go ahead and set up now is our walk back to our idle state. So the way we're going to do that is a custom event, and you guessed it, idle is going to go right here. Okay, now when we test this out, you should notice that it will kind of go from an idle phase to a walk phase, but it is not actually moving. And the reason why is because it's trying to use X as the factor by which it moves. And right at this moment, X is set to 0, so X never moves. If you were to set the X to 1 there, you'll notice that it goes that way. And if X goes to -1, not only does it move back to the left, but you notice that it doesn't flip. And so that's what we're actually going to fix right now. Okay, going into our walk super state, we are actually going to go into where we had left over here and right there. What we're going to do is let's start with left, and we're going to make it to where it not only flips, but it's going to set the direction to go left on the x-axis. So let's right click and break that, and then we're going to go to a sprite renderer, flip X. And what this is going to do is it's going to set the flip X to true. So it's going to flip that sprite just on the x-axis. And then what we're going to do is we're going to set X for our object variable to a float of a -1 right there. So every time it is now swapping directions going to the left, it's going to not only move left on the x-axis, move left on X, it is also going to flip the sprite as it goes back towards the left. So we have that. Now we need to set up the right. So I'm just going to copy this right here. It'll make it a lot easier. So copy that, go back into our walk, come over here to right, break that, and hit paste. And now we have pretty much our whole code set up. We just need to change a couple things. Of course, we need to set that to unflip the X, and then we set this to a +1. Now when we test, we should notice that it randomly decides to start walking either to the left or to the right. And there it goes to the right, and it might stop. It might go to the left, it might go to the right. Let's find out. Okay, so it's going to go right some more. Now you should notice a problem if it doesn't flip back. Okay, so it did flip back, but there's a problem that we're going to have here, and that is that if it goes over here to the wall, what you should notice is it's going to keep walking into the wall. The other thing it's going to do here is it's going to walk right off a ledge. So we're going to fix that so it doesn't do that anymore. Okay, to ensure that this is not going to walk off a ledge or continue walking whenever we get into a wall, what we're going to do is going to right click our skeleton here, and we're going to create an empty object here, and we're going to call that, let's call it blocked R for blocked right. Now this is going to be sitting at 0, 0, 0 on our transform position here on the skeleton. The skeleton is still where it was, but this is in the center of that skeleton. And what we actually need this to do is scoot over just a little bit. So we're going to type in 0.35 here on the X transform, and we're going to add a let's add a box collider 2D right there, and this is actually going to be a trigger. So what it's going to do is anytime it enters the wall or platform, it's going to trigger. And we're going to set that up. Let's set the size, I think, to 0.1 on the X and the Y. And what you should notice is that it puts it over here just a little bit outside of the reach of its box collider, so that when it triggers, it's going to stop walking. That's the idea of what we're going to be doing here. We're also going to add a flow machine to this because, and I believe we can actually set this to embed here, and that way we don't have to create a new graph, and everything that we need is going to be inside this game object. But we're also going to need to go ahead and set up another game object. So we'll just right click on that blocked right there and create an empty, and we're going to call this one ledge check. So this is going to be checking for a ledge, and the other one is going to be checking for a collision on the wall. So this one can actually be setting on 0, 0, 0, but it is going to need a flow machine, and we are also going to set that to embed. And once we get that done, we can just select our blocked right game object here, and we're actually going to duplicate that, and then we're going to call this one blocked L for blocked left. So we have a blocked right and a blocked left. Now this needs to be on the left side of our enemy, so we're going to type a negative 0.35 here. And so when you look at both of them, it should have one on the right and one on the left. Both of them should have ledge checks with embedded flow machines on both of those. Let's start with the ledge check on the blocked right. What we're going to do here is what we need is a line that's going to come straight down from this game object. So this is sitting at 0, 0 on a negative or a positive 0.35 right here. So what we're going to do is we're just going to use this update node real quick, and we're going to do a what's called a raycast. So this is a physics 2D raycast, and what we need is the one that is origin, direction, distance, and layer mask. So we're going to shoot that down. The origin, where it's going to start from, is going to be on get position. So get its own position, transform get position. So it's going to start the line from wherever it is, and then it's going to send it downward. So we need it as a -1 on the Y. So -1 on the Y axis will go down. That's what that's doing. We need it to go a distance of 1 unit, which will just send it down 1 whole unit. I believe the whole enemy is 1.5, so if you start it from the middle, it could actually be like 0.76 and still be okay. But we're just going to set the distance to 1. And then for a layer mask, we need a layer mask literal. And the layer mask that we are going to use is the platforms layer that we set up in our 2D player controller. So we're going to use that platforms layer, and just basically show you how this works if you do not have this. I have a grid set up, so let me scroll out here. I have a grid set up with a background. It has the background items, which are all the bookshelves and stuff. It's just a tile map here. And then the platforms, I'm using a tile map 2D collider with a composite collider set to polygon, and what it does is it gives us those platforms. So what this is going to be checking for is that platforms layer right here on my grid. And as that is shooting down, we need to run this into a branch. So basically what it's going to be doing is it's going to say, shoot this line downward, and that line that's shooting down, is it hitting the platformer layer, yes or no? If it is, then what we need to do for this one is we need to set the object variable on the parent of parent. So it's 2 layers in. We need the object variable on the skeleton. So what we're going to do is we're going to do blocked right here. Type in blocked right, and we're going to set blocked right to false, because it's not blocked right if it is catching the platform underneath it. When it runs off the edge, what we're going to do is tell it we're going to set the blocked right to true. I'll do that in just a second. First, we need to access this object variable on our skeleton, not on our ledge check. So what we're going to do is we're going to get the parent of the parent. So get parent. You're going to do this twice. So what this is doing is it's saying get the parent, which is the blocked right, get the parent of that, and it's getting the skeleton. So here it's going to set the object variable blocked right on our skeleton to false. And we're going to do just the opposite, going the other direction. Let me go ahead and label this right. So allow move right, and that's going to, you know what, we're going to set that one to red because it's turning it off. And here I'm going to copy this, and I'm going to paste it right down here, because pretty much we need to do the exact same thing. How about we're going to, oh, wait a minute. So allow is a good thing. So we need to allow that one. And then right here, we need to stop moving right. If it's checking the platform and it's not seeing it, we're going to stop moving right. And then we're going to set the block right to true. So if it's blocked right, we don't want it to move right anymore. And here we're just going to label this platform check. This is going to be yellow because it's checking for something. Now what we can actually do here is we can just copy this whole unit here and put this into our ledge check on the block left. But we need to set this to a different object variable. Instead of block right, we need it to be setting the object variable for block left. And of course we're going to change these labels real quick. If I can get my thing to stop There we go, block left. And, oh, come on. Okay, so what this is doing, so notice you'll have one that's firing from the left side and one that's firing from the right side. And if it's not picking up anything on the right or the left, it should stop the unit. Now, we can check this real quick just by throwing him up here, because you'll notice, let's just do it over here because he's got a shorter walk distance. Oh, we actually have to fix something else before we do that. Let's go ahead and actually work on our block right and left, because he's just going to walk off the side until we fix this. So let's go ahead and do that real quick. So on our block right, we're going to need to go ahead and set up an on-trigger, enter, and exit. Now, this is another one of those super units that we used on the player controller. So I already have this one set up. On-trigger, enter, and exit. And we're going to be checking for our platforms layer right there. So I've used this a ton of times. I would continue to use this because this is an awesome macro. That's basically what it is. It just has the so the input, all it has is a tag that has a default value, so you can edit that outside the graph. And then the output, of course, here has a enter and exit and an object there that you can use. So we're going to be using this to determine if that little square, just one second, if that little square on our skeleton right here comes in contact with a wall, we want to stop it moving to the right, and we want to turn off this little ledge check. And the reason why is because if that runs into a wall over here, it's going to continue to tell it can continue to move because it's picking something up. So we need to disable that. The way that we're going to do that is whenever we enter a platforms layer, we are going to set, let's do a flow machine set enabled, and we're going to turn the flow machine off on the child object. So get child. So if this little square comes in contact with a wall, we want to turn that off. So that's what we're doing, is we're just setting the flow machine off. And we need to set the object variable. We need to set the object variable block left to true. And this is not on this game object. This is actually on the parent. So we just have to do this one time. Get parent. And that is going to take care of, we need that one to be true. It's going to be taking care of not allowing it to move left anymore. And we are still going to have one more thing that we're going to have to set up for this to work correctly. So stop, move left, and then disable that, disable the ledge check. So let's go ahead and put that in there. Disable ledge check. And for the whenever it exits the platform layer, we need it to do just the opposite. So let's go ahead and copy all this. Now, let's just copy the nodes here. You know, whatever. Copy and duplicate that selection. Oops, I grabbed everything there, but that's all right. I'll just delete this one right here. And then we need to run that into here. We're going to turn that flow machine back on whenever it exits. So we're going to enable the ledge check instead of disabling it, and make that green. And then the stop move left, we're actually going to tell it to allow move left. So we turn the block left off. And here, so we've got that set up. So now what we need to do for our right side is just copy this and then go into, actually that is the right, isn't it? Oops. I tell you what, let's go to block left. I didn't realize I was in the other one. Okay, so this is block left. That can stay. So let's go over here to block right now, and let's turn this to right. And this one right down here is right. And let me fix the labels real quick, because I'm OCD and I want everything to be pretty. Everything needs to be super pretty. All right, there we go. All right, so now we just need one more little object to ensure that this is actually going to work correctly. And the where we're going to do that is, you remember I told you that we have, oh, let me get out of here. Oops. Where am I at? Okay, here, on our skeleton, you remember I told you that these were actually going to be different. Right now they're the same, but they needed to be different eventually. And so since this one is left, what we're going to need to do is we're going to tell it, if this is block left, so let's do a branch here. We're going to run this into an update, and if the block left variable is ever true, so block left. And we couldn't search for it in the other ones because it wasn't an object variable on that game object. It's on the skeleton, so you can actually check that here. So we're going to check blocked left check here. I'm going to set that as a yellow one. So if the block left is ever true, what we're going to do is we're going to go back to a custom event. We're going to trigger the idle. So it's going to just immediately trigger it back from walk back to the idle state, which is right there. So let's go back into our left. Let's finish setting this up. So we can only move left if block left is not true. Now let's take the same little set here. I'm just going to take this and copy. Oh, actually all three of these, aren't I? Yep, that one right there. Let's copy that and let's go into right. Now that that is set up, and let's break that little line. Let's paste this. And now we're going to set this to block right. Notice you have all of your object variables because this is on the skeleton itself. So let me set that up, move that, put this right here, blocked right check. And this is checking if it's blocked right. If it is, it's going to go back to an idle state. So let me put that in there. Back to idle, or transition to idle. And these labels are not necessary, by the way. It's just my thing, I'm telling you. So, okay, so now we have it set up to where whenever the skeleton is moving left or right, if it ever has a blocked right variable, it should not move right anymore, or vice versa on the left. So now that it's sitting up here on this platform, let's check. Actually, let me put it in full screen here for you. Now that it's in full screen, it should stop. It should not walk that way anymore. So it's going to sit there and sit there and sit there until it determines to go left, or it's going to go right back to the right. Now we actually need to do a little bit more work, that if there is a decision to go right and we're blocked right, it needs to decide to go left. So let's go ahead and set that up real quick. Okay, just to make it look a little bit more intelligent, we're going to go into our enter state. So skeleton, non-combat, walk, and now enter. And what we're going to do is just grab these two units right here, and we're just going to scoot them over just a little bit. That way it's not standing there looking at a wall for too long. We're going to come up here to a branch. So this is going to be a true or false statement. If it's true, it's going to do one thing. If it's false, it's going to do another, or nothing at all. We don't have to have it doing anything. But here, the branch is going to duplicate that again. So it was a random decision. Remember, it's like a 50-50 chance to go left or right here. So we're going to do a blocked. We're going to get the blocked right variable because this one is going into the left, I believe, right? So get block right. Is that right? I think I'm losing my mind here. So let's change this to block left. So if it's going this way, if it's saying, okay, decide to go this way, and it's block left, we need block left to only go left if this is false. So if it's true, it's going to go to the right. Now the same thing, I don't think it actually matters which one of these you put here because it's all random anyway. But block right, so we're going to run that into this branch here, and it's saying, okay, go this way. Well, if it's blocked right, we don't want to go right. So we only want that to be true when it's false, and then this one comes down here. I know that's kind of a little gymnastic move that we're doing right there. It takes a little bit of finesse to pull this off. But basically, the idea is pretty sound. If it's ever blocked left or right, it's not going to go that way. It's going to go the opposite way. So we want to check for blocked left and right and do just the opposite if it is true. Does that make sense? Hopefully that makes sense, that this is correct. So just double check all your lines there. It's not super complicated. I mean, I've made way more complicated stuff than that. But if block right is false, then it can go right. But if it's true, it's going to go left, and vice versa for left. All right, so when we test this out, we should notice that he doesn't stand there for a long amount of time. 1 to 3 seconds, he'll move. So if he gets to where he's blocked over here on the right side, so he'll stop, and then 1 to 3 seconds, he'll move back. 1 to 3 seconds, he'll move back. 1 to 3, so he wasn't actually all the way to the end there. He stopped before he got there. There we go. 1 to 3 seconds, he should move. 1 to 3 seconds, he should move. Okay, that's what we need. All right, so one more thing let's check for real quick is let's take this little game object and let's put him over here against the wall. So he should also stop whenever he's walking into the wall. So he stops on a ledge. We got that set. but he also should stop moving when he goes into the wall and now go back the other direction. Yeah, we are set up, and we can actually check just the other side real quick just to ensure that everything is working correctly. There we go. So check that. He stops on the right, and he should also stop when he walks into a wall and not continue to walk. And he does that, so he is set up for idle mode. Nice. Okay, now that we have the non-combat mode pretty much set up, we are going to need to start working on the combat state, how he attacks the player. Now, essentially what needs to happen in combat mode is he needs to chase the player, he needs to stop when he gets close enough to attack, he needs to attack, and then he needs to go back to sitting there idling until he can attack again as long as he is in range. So the way that we're going to set up the attack is to create some attack points on the skeleton. But before we do that, let's go ahead and set up the macro. So let's go into our player controller, macros, enemies folder, skeleton folder, and let's do a new flow macro here, and let's call this attack point. Once we have that flow macro made, let's go ahead and we're going to set up some units here that we haven't called yet. We're going to do a custom event here, and we're going to tell it anytime the attack custom event is triggered, then we need it to do certain objects. So what we're going to do here, and basically what we're going to do is going to set this up, and then we're going to put it on a game object. I'll show you how it works. So we're going to use a overlap circle 2D, and we need one that is point, radius, and layer mask. So the point of reference that it's going to use here is get position of whatever the game object that we're going to put this on is. So do it in the center of there. We're going to set the radius to our attack radius. And, well, oh, I don't have, you have to use an object variable and type that in. Variable, because it's not on an object yet. It's not on the skeleton. So let's do attack radius. Make sure you spell that correctly. And then for our layer mask, we're going to come down here to a layer mask literal. And then we're going to, what we're going to be searching for is anything on the player's layer. Now, the only thing that should ever be sitting on the player's layer is the player. So right here it has layer of player. Skeleton, by the way, needs to be on the enemy's layer. So go ahead, just change this object, not all the children, because we don't want to hit any other colliders. We just want to hit the enemies here. So our enemies is on the layer enemies, and going back to our attack point here, we're checking to see if anything is on this. Now this is actually going to be setting on a child object of the skeleton. So let's go ahead and get parent here. So I'll show you exactly where we're going to set this in just a second. But what we need to do here is we need to do what's called a null check. So basically what it's going to be doing is anytime an attack swings, as long as it's attacking, it needs to be checking for anything on the player layer. If it doesn't hit anything on the player layer, then we don't need it to do anything. But if it's not null, meaning it does hit something, null is empty. If it's not empty whenever it hits, then we need to actually trigger the damage on the player. Now we actually already set this up, custom event. We're going to trigger custom event called damage. And we're actually going to use an argument here. We are going to send the damage over to the object that it hits. So what we're going to do here is we're going to use this little collider that's got right there. We're going to get game object. Is that right? No, we need a collider 2D. So let me just type it in. Collider 2D. Get object. There, get game object right here. It's going to find that collider that it hit, and then it is going to it's going to trigger this custom event on that game object. Now again, I already have this set up on my player controller, and I'll show you exactly how I have that set up. Just 1 second, let me finish this. So we're going to do an object variable here, get object variable, and the object variable that we're going to be looking for is our attack damage. So whatever the attack damage is on our skeleton, which I believe is set to a 1 right now, this is going to be on a childed object. So we're going to get the parent of this, going to find the object variable on our parent because it's going to be 1 layer down again. Now this is going to send the damage to the player. So I'm going to set this as send damage to player and set this to green, and then this is going to be our player check. So is a player in the circle cast. So player in circle cast. So this is going to be a check. So I'm going to make this yellow. Now, this is all you basically need, but for a visual indicator, I'll tell you what, let's go ahead and set that object up so that I can stop talking about it and you can see it for yourself. So right-click our skeleton, let's create an empty, and let's call this one attack R. And we're going to move this to the top of the list here because we're going to reference that later. And then we're going to give this a flow machine, and we're going to select that attack point. So you just grab that from right over here and put it right in here, and now it's going to have that game object, which is why we're using the parents here. Notice to get the parent, the attack radius, and the attack damage, and then we're going to send that to our player. Let me show you where that's coming out of our player real quick. So on our player, under vulnerable, I believe, we should have, yeah, we have a custom event called damage, and it's going into our damage super unit. If you want to know how to set this up, go back to that player controller, and I'll show you exactly how to set all this up. But here we go. We're setting the damage here. Now, we want to know where this is attacking, and basically we just need a visual cue. So it's not going to show us anything. It's going to perform the action, but we have no idea where it's hitting when we're outside of play mode. And the way we're going to fix that is with an on-draw gizmo selected. So on-draw gizmo selected, so that when we select this game object, it will show us what we're looking at. So we're going to do a gizmo set color. We're just doing this. I'm going to change it to red instead of white so it's a little bit more visible. And then we're going to do a draw wire sphere center and radius. So the center of this object is going to be on get this position. So get the position of this game object. So get position right there. And the radius is actually going to be our attack radius on our skeleton. So we're going to get the parent of this object. Now what you should see here is now you have a circle that's taking place. Now we actually need to set this in the right place, though. It's not in the right place right at this moment. So in order to set this right, you can do one of two things. You can use the values that I'm about to give you right now, or you can actually see the logic. So let me just do the values that I know it's going to be. 0.05, I think. There we go. So how I got that is if you actually look at the attack 1, and it gets right about there, you notice that that's the end of the circle. So I kind of wanted to make it, as long as he exits the swipe, he's okay. But that's pretty much how I got that value. So we're going to do attack right there. And again, this attack radius, so if you were to take the skeleton here and you were to move the attack radius to, let's say, 0.75, it's going to be less of a hit cast that's going on right there, that little circle cast. So I'm going to set that back to 1. Then what we're going to do is we're going to duplicate this game object, and we're going to call this attack left and move it right up here to number 2 in the list. And this, the only difference here is it's going to be a -1. So as we click back on our skeleton, and let me just put him back on like put it back on idle, so that there you go. You can see these are the directions that it's going to attack. So you have attack right, and then you have attack left. So what we need to do now is actually trigger a chase for the player. So whenever he gets close enough to the player, it's going to start chasing him, and that way he can start getting close enough to where he can actually hit him now. Okay, now that we have that attack point finished, now let's go ahead and set up one more that we're actually going to be calling in this next graph. So right click on our I think I'm actually in my skeleton folder. So macros, enemy skeleton, right click, create bolt flow macro, and we're going to call this one player X position. The purpose of this one is going to be essentially just checking the position of the player versus the skeleton game object. So right here, let's go ahead and let's just double click this and open this up. Right click and create an input. And this is how we set up a super unit that I was showing you just earlier here. So we're going to do input, and we're going to run that into a branch. And what we're going to be doing is checking the direction of the player versus the skeleton game object. So let's run this into a grader node, and let's see. Let's just get the position of the player. Get position of the players. We're going to duplicate this, set another one right up there. And I actually have my player set up as an app variable. So we're going to get application variable, and we're going to see where the player is. Now again, I set that up in our 2D player controller, and I wasn't lying to you when I told you that you probably need to complete that one first. Get X, so we're going to get the X there. We're going to duplicate that unit. So we're going to get the position of the X of the skeleton here, and if it is greater than the player, then we're going to run that into an output and perform certain actions. So let's go ahead and set up that output real quick, and then we'll just work through the logic one more time. So we need a left, and then we need a right. So what this is doing, once again, is it's checking the position of the skeleton, so of itself. It's getting the X, and if the X of the skeleton is greater than the X of the player, it means that the player is to the left. If it's not, then his player is to the right. So that's essentially what that is doing, and we're going to be using this node in just a second. Player position check, and we're going to set that to yellow. Okay, now just to show you where I set up the application variable, if you're not using my 2D player controller, under my, I think it's under non-combat, is that right? So under my master node, I have a little singleton principle that as the game starts, it just sets itself as the player app variable there. So I'm able to call that on that player X position. That's what that's doing. Okay, so now that we have that set up, let's go back to our skeleton, and we're going to need to add some nodes to the idle flow state in the combat mode, but we actually have to set this one up really quickly. Let's go ahead and rename this start to idle, and we need 3 things to happen. We need it to sit still, we need it to chase, and we need it to attack. So let's go ahead and set up another super state over here. We're going to call this one chase. And then this one right over here, we're going to set up a super state called attack. All right, and so we're going to make a transition from idle to attack, from attack back to idle, and then the same thing from idle to chase, and from chase back to idle. So that should be ready to roll on that. So let's go ahead and open up the idle state, and here we are going to be using that player X position. But first, what we're going to do is on the inner state of idle, we need to play that animation. So animator, I always fix that up. Animator, play, state name, and we're going to play the idle. So if it's ever standing still, we need it to set still. So we play the idle animation. So play animation. Set that to purple. Okay, and now what we're going to do is we're going to do a series of checks. Now, this first one here is pretty much something that I arrived at by lots of testing. I don't want the enemy to move, so I'm just going to go ahead and give this to you now early. So this is an object variable, or get, how about get dead? Yeah. So if the enemy is dead, we don't want it to do anything else. So this one is a dead check, and set that to yellow. Okay, so now I'm just going to take that branch and that object variable, I'm going to copy it, and essentially what we're doing here is just a series of checks. So we're going to do a dead check, we're going to do an in range check, which we haven't set that up yet, but we will go ahead and make this work. Range check, and make that yellow as well. So if the player is if the skeleton is not dead, and if it is in range for attack, and it is going to attack, we're going to set up a new object variable here, branch. So the can attack value is what we're going to use here. So can attack. If it is in range and it can attack, then we are going to trigger the attack custom event. Trigger custom event, and then attack. Yeah. Okay, so this is going to trigger the attack. Set that to green. Now, if it is not dead and it's not in range, then what we need to do is we need to check the direction of the player. So with that super unit that we just made, we're going to do player X position. We're going to check, is the player left or is the player right? So if the player is left, we're going to do a check here, because remember, we don't want it walking off of ledges. We're going to do a blocked left check. So get the block left. If it's not block left, then what we're going to do is we're going to do one more branch here. And again, this is just from testing that I figured this out. So I'm just going to go ahead and give you the entire code here, and then I'll explain why we are using that. So we're going to do an idle check. If it's idle, okay, and it's just to ensure that it's not moving when we don't want it to. Blocked left. We're going to do that right there, and then we're going to copy this and paste this right down here. If it's to the right, we need to check block right. So if it is not blocked left or right, then we're going to go into one more check just to ensure, is it idling? Because if it's idling, if its idle is set to true, well, then we don't want it to move anywhere, because there are some situations where we would have it setting idle. Okay, now if it's not idle, then what we're going to do is we're going to trigger the chase custom event. So we're going to tell it to go chase the player. So we're going to do this right here, trigger chase. All right, there we go. And now that that idle mode is set up and ready to roll. Okay, now that we have that the idle form set up, let's go into chase, and let's go ahead and set up this state as well. So let's set this up as enter, and then we're going to do another flow state over here. This looks very similar. You've seen this before to the non-combat mode, but the reason we had to set this up again is because it's in a completely new state now. It's not in combat mode anymore, where we'll be walking and deciding where it's going. Now it is in combat mode, and we need to set up the walk phase. I think I have it set to enter, but it's supposed to be chase. I'm not sure how that happened. Okay, so anyway, so it's in the chase state. Oh, that's how it happened. That was supposed to be enter, because I had that one still selected. So now that it's in this state, we're going to set a transition from enter to left, or enter to right, excuse me, and then we're going to make one more transition from left to right, or right to left. Now, you should never need these, but just in case the player jumps over the enemy's head and it's in the process of moving, it's not out of range, it's going to switch from left to right as well. So let's go into the enter state, and let's go ahead and set this up. This is kind of our decision on when we're moving to a walk state. So we're going to do our animator play state name, and then we're going to tell it to walk. So we're going to play this animation. Play animation. And now that we have set up our animation, we are going to need to decide whether we're going left or right. Now, the way that we're going to do that, you can delete those two units. You're not going to need that. The way we're going to do that is we are going to first perform a check. We're going to see if the branch is forcing it to idle. So is it in idle mode? And we're going to set this up in our state handler. That's pretty much going to handle all of our code. If the code happens to come in before, you know, like it's trying to move and it idled at the same time, we're just doing one more check here just to make sure that it is actually going to send that back to a custom event called idle. That's going to transition back to idle mode. Okay, so once that is done, now we are going to check. So if it's not in idle mode, we need to check the player's position, because that's going to be the indicator on the direction that we are going. So player X position that we set up just a minute ago, is the player to the left or is the player to the right? Now, once again, we're going to have to set up a block left and a block right check. So let's do a branch here, and we'll just duplicate that one more time, and we'll set up an object variable. get object variable, is it block left? Let's duplicate that. Or is it blocked right? So if it is blocked left or right, in other words, it's reached a ledge or a wall trying to get to the player somehow, we need it to stop moving. So if it is blocked, then we're going to go to that custom event right up here. Let's just do this one. So if it is blocked left, it's going to go back to idle. But if it's not blocked left, then we're going to trigger a custom event and make it left. And the very same thing is going to be true for right, so we're going to set this to right. If it is not blocked right, then it's going to go right. If it is blocked right, well, then we're just going to go right back up here to this custom event. So let's see here. See if I can get all this into one. You know what? I'm just gonna do it like that. So move left or right if not blocked. Okay, let's do it like that, and kind of squish them together a little bit more. I don't know why, but bolt visual scripting for me is just one of those OCD things that it really just sets me off. If all my lines are not perfect, I don't know, maybe it's not for me for that reason. I'm super anal about some of this stuff. Trigger idle. Maybe I shouldn't be. I don't know, maybe one of these days I'll come back and look at this thing and be like, oh, that looks pretty nice. In my experience, though, I've always come back to my graphs and it's just been ugly and terrible, and I hated it. I'm like, oh, that's so bad. So anyway, okay, so the enter is now set up. Now we need to actually set up our flow states for left and right. So let's go ahead and do that now. So once again, as we come into this, we're not going to need the exit state, but as we come in, we are going to check idle one more time, just in case, just from one frame that it got fired, that it might be trying to tell us to go to idle. So we're going to do that one more time. Do an idle check here. Get idle, idle check. Come on, idle. Check. There we go. All right. And then if it is going to the left, well then, and it's not idle, we're going to need to flip the X. Sprite render flip X, just like we did previously in that transition, if you remember, and we're going to set the X variable to a -1. So a float of -1, and then we're going to set direction here. So this is just going to be for left. It's taking care of all that stuff that we were taking care of in non-combat mode. If it is idle, for some reason that object variable gets flipped before that, we need to go back to that custom event idle. It might not be incredibly necessary, but I just wanted to be safe just in case something is getting flipped. The idle is getting set to true. It's just one of those little fail safes we're going to put in there. So trigger idle. And then as we have now entered this state, we're not going to exit unless idle is true. So what we're doing now is we need to check and see, is the player in range as it's moving to the left. So if the player is ever in range, yeah, get in range there. So if the player is ever in attack range, then we're going to trigger that idle. So trigger the idle. Range. In range. Yeah, there we go. In range, question mark. So if the player ever gets in range, let's trigger that idle. Okay, if it once again is blocked left while it's moving left. Oh, come on. Branch. That block left was from my player controller here that I had set up previously. Okay, blocked left, get blocked left. That's what I need right there. So if it's ever blocked left while it's moving, then it's going to go, of course, back to the idle. But if it is chasing the player and it's not blocked left, then we can now do that move variable transform that we had set up previously. You probably recognize all of this. Now the multiplier is still going to be get x, the x variable right there. But this time for the speed, instead of the regular speed, we're going to be using the chase speed. So get the chase speed, because that is actually double the pace that we had set up. So this is going to be our move function. And now that we have that set up, we are actually going to copy all of this. So let's copy that. And then we are going to set the very same thing up for right with a few changes here. So the flip x is not going to be true, and this float is going to be a 1. And then we're not checking block left, we're checking block right. So let me change that little label right there. And I think that's it. Yeah. Okay, just a little change we need to make now is setting up our transition. So from enter to left, we need a custom event here called left. And that one's there, so I'm going to copy this, and now I'm going to go into this one right here, and we're going to paste it, and we're going to say this one is right. So if it ever tells us to go right instead of left, it'll go right. And then on these two transitions, what we're actually going to do is we're going to use an update node. So if we're going to update, and we're going to player X position. Player X position. Now this one is going from left to right. So what this is saying is if the player's position is to the right of you, go right. But if it's to the left, let's copy this. It's going to go back the other way right here. So left. There we go. So now it is going to check all of that. And the last thing that we need to set up is a chase back to idle state. So as idle comes in, we are now going to, let's do a custom event here. Custom event. This is chase. So from idle to chase, we need a chase custom event. And copy this and put this right here. And this one is going to be from chase back to idle. And I believe if we test, it's not going to do anything because we don't have our aggro range set up yet. Before we set up that aggro range, let's go ahead and set up the attack from the skeleton game object. Now, on this skeleton, there are actually 2 attacks. So you have attack 1, which is kind of a downward swipe, and then you have attack 2, which is more of an upward swipe, as you see that. So what we're going to be doing for this is we're going to need to build a system to make a choice between attacking with attack 1 or attack 2, and it's going to have to go either to the left or to the right. So coming into our attack super state here, click on this start, the one that says start here, and let's just rename this attack choice. And then we're going to need 4 new flow machines. And the reason we're going to do 4 is because you have 2 attacks, 2 to the left and 2 to the right. And this attack choice is going to decide which one of these it's going to go to. So let's create 4 new flow machines and put them right over here, just like that. And this one is going to be attack 1 left. Let's do left right there. And attack 1 right. And then obviously this one is going to be attack 2 left and attack 2 right. And we are going to need transitions from attack choice to each one of these. Now it doesn't have to come back, but it does need to go to it. So after the attack is done, then it will go back to an idle transition. So you don't have to worry about sending the flow back in to attack choice. Okay, so let's go ahead and take a look at this attack choice flow macro here. Whenever it comes into this state, we need to tell it which way to go, but we also need to initiate our attack cooldown. So go ahead and delete the update, and on exit state, you're going to need that. We're going to control the cooldown with the state handler, but we are also going to have to set the object variable can attack set can attack to false. So, and that is going to initiate the cooldown. I'll show you how as we get to that section. But if it ever goes false, it starts the cooldown. Right here is where we are setting that to false. So we're going to initiate attack cooldown right here. So I'm going to take that to green. And then we are going to set our attack 1 or attack 2 with the attack integer. So going over here, let's go to a branch, and it's going to ask the question, is it attack 1 or attack 2, by using a less node. And we are going to run the A into attack int, get an attack object variable right here, and then if it is less than 1, so if it's 0, it's going to go to the left. If it's or true, if it's 0, it goes to true. If it's 1, it goes to false. Now the way that we're going to be able to control that is by doing it with our code right over here. Let me go ahead and set this up as check attack integer. So it's going to start at 0, right? Let's assume it starts at 0 and that it is true. Well, now what we need to do is we need to add 1 to that number, so if it ever comes back through, it'll be 1 instead of 0. So let's go to set attack int, and we're going to set that to whatever it is plus 1. So add, you're going to use the scalar here because it's going to give you an integer here. Attack int is what we're going to be getting. So it's going to get the attack int, and it's going to add 1 to that. So let's go ahead and move this over just a little bit, and let me label this real quick. Attack int, add 1 to attack int, and we're going to set that as green. And then after it's done, then what it needs to do is it needs to check the direction. Is it going to the left or to the right? Now there's an easy way we do that is we just check the get flip X. Remember, if it's going to the left, we set it to set the flip X on the sprite renderer to true. So all we're going to do here to check our direction is get flip X, and this will determine whether or not it is facing to the left or facing to the right. So this is an easy way to get the direction. Get direction, and I'm going to set that to yellow because it's inquiring something. And now I'm either going to attack 1, so I'm going to attack 1 here because the attack 0 is going to be the first attack. Attack 1 is going to be the second attack. Hopefully that makes sense for the integer. So all this started at 0. So 0 is 1 and 1 is 2. That makes sense. Hopefully that's not confusing you. Lists always confuse me. But here we go. We're going to set a custom event trigger. And for this one, so if it is true, if get flip X is true, then it's going to be going to the left. So let's do attack 1 left. And if it's false, then we need attack 1 right. So the flip X is not flipped. The sprite renderer is not flipped. So attack 1 right here. So we're going to say attack. Let's just do one big thing here. Attack left or right. All right, and we will control that custom event. That's what's going to go into our transitions in just a second. So what happens if it comes in and it's already 1? Well, then we need to take this right here, and we need to set it back to an integer of 0. So now, next time it comes through, it'll go to 0. So we're going to reset attack int, and I'm going to set that to red because we're resetting something. Again, no rhyme or reason to that. That's just helpful for me. And now we are going to do pretty much the same thing here. So we're going to check and see if the sprite, or if the flip X, if the sprite render is flipped on the X. So if it is, then we need to go to attack 2 left, and if it's not, we need to go to attack 2 right. So that pretty much is your whole graph right there for making the decision on which way it goes. Now we're going to go ahead and set up our transitions here, and then we'll go into our attack sequence. So the attack sequence is actually pretty simple, but in each one of these you're going to need a custom event, and it's very simple. So this is attack 1 left, so we're just going to take that and put it into our trigger transition right here. Let me copy this, And as we go into the next one, we'll set that as attack 1 right. And then this arrow is going to go right into this transition right here. Just going to copy the whole thing. It's aggravating. Alright, just delete that, paste. And then this is attack 2 left. Oops. Attack 2 left. Copy. And then attack, whoops, wrong one. Attack 2 right. And now our transitions are set up. For each one of these transitions, this is going to be very, very simple here. We're just going to come into an on-enter state, and then we're just going to play the attack animation. So animator play, state name, and then we are going to tell this one is attack 1, which is what we had that that animation called attack 1 and attack 2. So as we come into attack 1 left, we need it to play attack 1. So that's very, very simple. Let's say play animation, and then we're going to set that to purple. Now, we are also going to have to tell which game object we want to attack. So since this is attack 1 left, we need it to select the second attack point in the list, and we need to tell it to go ahead and initiate this custom event attack. So the way that we're going to do that is actually with an animation event. So let me get back to my attack 1 left here, and then we'll go ahead and set up that custom event. So we are going to trigger a custom event, and we're going to do that attack, and we need it to trigger on that game object. So we're actually going to go here to get child, and the one that we need, since this is attack 1 left, we need attack left. So we're going to have to go to the second game object in the list. Remember, list start at 0, so 0, 1, that is the second game object in the list. Now, how are we going to trigger it on that game object? Well, we are actually going to use what's called an animation event, and I'll show you how to set this up. This is very easy to do. Let's just say sword attack is our animation event. Now let's go ahead and go set that up real quick, and I'll show you how this works. So coming into our animation here, let's go to attack 1, and let's figure out the point that we want to attack. So right about there is where we want an attack to happen. Now right here on this little tab here, you see add event. So if you will click that, now you have to have a flow machine on whatever you're trying to animate as an animation event, or else whenever you click this little drop down in the inspector, you're not going to see anything. But what we're going to look for here is trigger animation event, and I believe we said what did we name that? A sword attack. So we need to call this sword attack. Now we also are going to need one more animation event as we come to the end. So let's go ahead and set that right now, and let's say we're going to call this one, so trigger animation event, let's do attack end. And so this is the end of the attack. So whenever this triggers, we're going to need an attack to happen on attack left, and that is what's going to happen. It's going to be listening for that sword attack, and when it happens, this right here is going to send that attack point on attack left. So attack left trigger. So set that to green. Now this is pretty much all we need to do to attack. So let's go ahead and copy this, right click it, copy, and we are going to do the same thing for right. The only difference here is we paste that in there. It's still going to play attack 1, but it doesn't need to trigger on the second child. It needs to trigger on the first one, because here we have attack right. Now the other two are relatively simple as well. The difference here is that this is attack 2 left, so we need attack 2 to play, and we're going to have to go into attack 2 and set up the same thing. So this is going to be sword attack. Let's see here, on the trigger animation event, so we're going to type in sword attack, and then right here we're going to set up another one and call this one attack end. So this is the end of the attack, trigger animation event, attack end. Alright, so now whenever we're in our second animation, it should trigger the sword attack, and it's going to attack on the left. So let's copy this one more time, and let's go into that last little attack point, and let's paste that in there. And what needs to change here, do you remember? It's going to be on the first game object instead of the second. Now I gotta go all the way back in there because I clicked the wrong thing here. It's going to be on the first child, not the second one, so this needs to be 0. So attack 2 on the right. So whether it's facing left, it's going to tell us, this attack choice is going to say, is it facing to the left or to the right? Okay, we'll attack 1 or 2. So that's basically how that's going to be set up. Okay, the last thing that we're going to need to set up for that combat mode back to attack is obviously these two transitions. So from idle to attack, we need a custom event that is attack. And just to keep things nice and organized, we don't want something else triggering when it's not supposed to, so we're going to call this one combat idle. And I'll show you where to plug that in the state handler in just a few minutes. But that should be what we need for those two. Okay, now very quickly I need you to go ahead and set up 3 new super units just by right-clicking, hit create, bolt, flow macro, and we're going to make 3 of those, one called range check greater, one called range check less, and one called X range to players. So just go ahead and check the less first. This is what this flow graph looks like, and basically what it's doing is it's checking the distance. This is a vector 3 distance between the position of the player and the position of the skeleton game object, and it is just determining if that distance is if the range value that we're going to plug in is less than the distance, and if it is or isn't, and I'll show you exactly where we're going to set those up. You need one for less, you need one for greater, and the reason we're using super units here is because we're going to use this multiple times. So this is doing the exact same thing, but we're checking to see if it's greater or equal. Now you might be wondering, like, why are we using 2 when one is less and the other is greater? Because it's not just greater, it's greater or equal. So less or equal or greater or equal, we want to make sure that those are different. So the last one here that we need is X range to player. And again, on all these range values for the input node here, that needs to be set to default values so that you could theoretically set this outside the graph. Now what this is doing is it's checking if the position of the skeleton on the X minus the position of the X on the player is less or equal to that range value. Or if the range value is less or equal to that. Now you'll notice here that after I do that, I'm using an absolute value here. And the reason why is because we don't ever want that to be negative. We want it to go back into being positive, and that's how we're going to check the distance. So it's a range from the skeleton game object over here to the player over here, and we always want that to be a positive number so that we can get the right value out of that. Okay, in order to be able to test these changes we've been making out, we need a way to transition from non-combat back to combat, and we're going to do that through our state handler. Now there's quite a bit that we need to do with this. Let's go ahead and start first with our attack cooldown. So our skeleton is going to attack the player, and we need it to initiate a cooldown. So the way that we're going to do that is we're going to run an update node into a branch, and then we're going to check to see if can attack if it can attack is ever false, then what it's going to do is it's going to initiate a cooldown sequence. So can attack question mark and set that to a yellow right here. So we're running that variable in. If it's ever false, well then we want to start that cooldown. So running from false, we're going to go into a timer, but we're not going to use as you make a timer, we're not going to use start, because otherwise that would just continually start it. What we're going to do is we're going to set that into a toggle here, and the duration that we're going to do that cooldown is the attack cooldown object variable, which I believe we have that set to 1. You can set that to whatever you want, but we're going to do this one as wait CD. So wait the cooldown time, and now once this is completed, we're going to do just the opposite. We are going to set the can attack to true. So that's the way that cooldown works. So oops, I need a boolean there, not a vector 2. So if it ever is not true, we're going to wait the cooldown time, and then we're going to set it right back to true. That's just an easy way to set up a cooldown. So attack, And in our code, when we attack, if you remember, when we attack, we set that to false. It's going to wait the cooldown, and it's going to make it to where we can't attack again. So that is it for the attack cooldown. Let me just go ahead and select all of that, and this is going to be our attack cooldown function. Now we need to make it to where it's possible to enter combat through our range. So we have aggro range. So what we're going to do is going to come down here and make another update node. And we're going to run that into our super unit range check less. Yeah, right there. And for our range value, what are we wanting to check? We're wanting to see if the distance between the player and the enemy is less than the aggro range. So we're going to get the aggro range right there, and then what we're going to do, if that is ever true, well then we are going to set the object variable combat to true. So if it ever gets in aggro range, it is now setting combat to true. So this is going to, right here, this is going to be the one thing that enables combat. And let me just go ahead and set that to green. And then we'll make a big overview here, and I'll move that inside this because I'm OCD. This is going to be our enable combat function. Now we need not only enable combat, we are going to need a disable combat. So the way we're going to do that is make another update node, update event, and then we are going to check, is the player in combat? Range. So it's just a good way to say we're not going to run this update unless the enemy is in combat mode. So if the enemy is combat, then we will want to do something. Combat check. Set that to yellow. All right. And what we're going to do now is we're going to say, is combat true? Yes, it is. Okay, well, is the player out of aggro range? Because that's how we turn it off. Range check greater. And here we're going to do the leave aggro object variable. So if it ever gets to the leave aggro, which I believe that one is set to 4 and this one is set to 7, again, you can have that set on whatever you want. Out of range. And then when that is done, so if it's ever out of range, if that's ever true, well then we're going to go up here and we're going to set combat to false. And this is how we're going to leave combat mode. So set that to false. Disable combat. And then all of this is one big function that we're going to set to disable combat. So now you have enable combat, you have disable combat, and we actually need an in range variable to determine whether or not our player is in range to attack. So the way we're going to do that is go to an update node right here, and then we're going to only fire this whenever we're in combat. So let me just borrow all of this, duplicate that, come right down here. Oops, I had that update node selected as well. We only want this to run whenever it's in combat mode. Otherwise, we don't want it to worry about it. Actually, whenever it's not in combat, we know that it's not going to be in range for attack. So we're just going to set in range to false, just as a way to check to make sure that he's not trying to attack the player in some funky way. All right, so set in range false, or set out of range true, however you want to word that. Okay, now we're going to come up to our player X position because we just want to check the position of the X. So player X position, this is the object variable that we made here, or the super unit that we made. And we want to know if it is in range of the enemy. We want to know if it's in combat and we can attack it. So what we're going to do here is we are going to do the set flip X to true. And the reason we're doing that is to make sure that it's following the player while it's in combat. We always want it to be updating that sprite. And then here we're going to set the object variable of X to a -1 because this is going to be to the left. We'll use a float there instead of an integer. -1, so we don't mess anything up. Okay, so this is going to be making sure that the sprite is staying updated and the direction is going to the left. So face/move left, and then we're going to copy all of this, and then we're going to copy all of this, duplicate that, move it down here. We're going to uncheck this and set that to a +1. That is going to be our move face. Face move right. And now what we need to do is we need to check if that range is attackable. So we're going to do a range check here, and we're going to do a range check less. And our range that we're going to use here, I had this hard coded as a value of 2. I think I want to change that to a 1.5. But in order to be able to do this outside of the graph, let's just go make one more object variable real quick, and we'll say attack distance here, and we're going to set that to a float, let's say 1.5. So then we'll move this in and set it right here. And just because I like to be organized, we're going to move that right up there. Now we have an attack distance. If it's saying, are we in attack distance of the player? And if we are, well, then it's going to set the in range. Set in range to true. So Boolean is true. And we're going to duplicate that and say, okay, if it's not true, well, then obviously we're going to set that to false. Right there. So this is going to be like an enable in range for attack. And the reason why we need this is so that whenever the skeleton is getting close, we need him to either chase the player if it's not in range, or we need it to stand there if it is in range. So this is the little object variable to control whether it's just going to stand there. So disable in range. This is going to be red. And then this is your distance check. Okay, make that yellow. Okay, and then this whole function here is going to be our enable/disable in range. Let's see if I can grab all that without grabbing something else. There we go. Okay, just gonna move this down a little bit so I can fit it into a square nice and neat. And this is going to be our enable/disable range function. Okay, so what do we got there? We got attack, we got enable, disable combat, and we have enable, disable range. Okay, actually a couple more things we're going to need to add here. We need an enable and disable idle. So if the enemy is in idle range or is attack range, but he can't attack yet, he needs to go to an idle. So the way we're going to do that is make an update node right down here, and we're only going to fire this once again if it is in combat mode. So let's make another branch, and let's say combat. There we go. Get that combat variable. So is this in combat? Check that. Make that yellow. So if it's in combat, we need to once again check the range, X range to player. And again, I had that hard coded as a 1.5, but let's just do attack distance now. Distance. So get attack distance. And let's say idle. So we're going to set idle to true if it is within that attack distance, but it can't attack. So set idle true. And then we need one more for set idle false. All right, and make sure that's unchecked here. We're going to come off of the false here, and then this is going to be distance, X distance, check. All right, and then this is going to be our enable and disable idle. Oops, try that again. Enable/disable idle. All right. Let's do that right there. Now we need actually one more thing, and that is, if you remember on our attacking, let me see if I can pull that up real quick. Whenever our enemy attacks, we have a little attack end sequence here. So this is the trigger for the attack, and this is the attack end. If we have that labeled right there. So we just need something that stays up all the time. So these are going to be switching. We need to make sure that that's in the right place. So let's just do it right here. We're going to do an animation event, named animation event. Where does it go? I didn't spell it right. Animation event, named animation event, and this one's going to be attack end. And actually, I think that will work. We don't need attack end 2. We just need attack end. So if attack end is ever triggered, we're going to do a custom event and say combat idle. All right, let's try that. Check that out. Okay, this is going to be our return to combat idle. And that should work. We might have to come in here and add a second animation event here in just a second. Let's go ahead and, what do you say we test this out? He's over here. Let me get my little player over there next to him. And we'll go ahead and put this on full screen. We'll check it out. Just 1 second. Let's see. Here we go. Uh-oh. He's not. Oh, you know what I forgot? I know what I forgot. We forgot the from non-combat to combat. We need to go ahead and put that in there. And the way we're going to do that is very simple. We're just going to do an update node and say, is the combat mode true? If combat is true, well, then we need to trigger that transition. So let's do a branch here and say, is combat true? Did anything ever set combat to true? Get combat. If it's true, we trigger that transition. So this is going to come right here. And let's copy all of this. Copy and paste. So if combat is ever false, we need to trigger that transition right there. Ignore those errors. Okay, so let's try this out. It's going to enter combat mode, and you should notice that if we ever get an aggro range, it's going to be much faster. Let me go around, actually. If I can get up there, come on. There we go. All right, you notice he chases me? Woo! Oh, and it hurts my player. Ouch. Now, one of the things you should notice here also is that he's just going to continue chasing the player. Now, if I can get out of aggro range, he should stop following me and go back to like just a regular idle. Let's watch what happens whenever we take this little skeleton and let's put him up on top here. He should not fall off the top, even though he's trying to chase us. Woo! Come here, buddy. So, all right, yeah, he should stop, and you should notice that as he comes over here, he's still in aggro range. He's still pissed at us, and we can actually, so he'll go back. Now we're out of aggro range. Let me get back in aggro range. He's like, oh, I want to hit you, but you can't. Okay, just 2 quick things that we want to address really quickly, and that is that if you notice that the player is pushing around the skeleton or the skeleton's pushing around the player and you don't like that and you want to fix that, like say for example here, now the skeleton is not able to push the player around, which by the way I have combat mode disabled. The way that you fix that, it's very easy. On the player, if you'll notice here, let's go to the rigid body. I've got his mass set to 100, whereas on the skeleton, the mass is set to a 1. So you could make it to where the enemies could push you around, or you could push the enemies around. That's completely and totally up to you. The other thing is that whenever we were in combat mode before with our skeleton, we were able to skip through the skeleton, and it wasn't hitting the player correctly. Like sometimes it would hit and sometimes it wouldn't. And the reason why is it does this attack, it was looking for anything on the player layer, and there's a lot of things that the player actually has on it. The player needs to be set to the player layer, but everything else underneath needs to be set to default so that when we're in combat mode here, it will always hit the player and not some other part of the player. So that should address any issues that you have as to why it might not be working correctly. Okay, now we know that the skeleton can hit the player. It sure would be nice if we could hit the skeleton back. So what we're going to do first is we're going to go into our hurt animation. So go to our skeleton here, and let's set up a couple of animation events. First of all, we want to know when the player the skeleton gets hurt, and we're going to set it right. We're going to set it right there. Let's do a animation event. We'll call it hurt. So hurt. And then we need one for hurt end. Since this is not looping, we need it to tell us when the animation event is over. So let's do hurt end. Okay, as we come into our hurt state, we of course are going to want to use the animator play hurt animation. So let's do animator play state name, and we're going to tell it to play the hurt animation. And once again, let's go ahead and label that play animation, and I'm going to make it purple. Okay, and now we are going to trigger combat, and the reason why we're doing that is because if somehow the player ever sneaks up on the skeleton, which should never happen, but if it does, we're just going to go ahead and make sure that combat is going to be set to true. This is a little fail safe here just to check and make sure. Some of this might be unnecessary. You can test it without it, but I just made sure that I had it in there just in case. So trigger combat, if not already done so. And now what we need to do is we need to subtract 1 health from the skeleton. So as it comes in, we're going to do set health, set the health object variable to whatever it is minus 1. So we're going to have to get the health. And I'm going to subtract the damage. Now, for the damage that we're going to subtract, I actually have a scene variable set up on my player, which should show us the sword damage. So this is the object, the scene variable that we're going to use. And again, I set that up in my 2D player controller. You can just use 1 here if you want. But I'm going to use sword damage because maybe in the future, let's say theoretically, you have a power-up sword or you get a level 2 sword. You want to do 2 damage. That's the easy way to set that. So we're going to subtract health here, and that is going to take 1 off of the health of the skeleton. Okay, now we need to do a health check. So as the skeleton is taken damage, we need to see if the skeleton is dead. So let's do branch here, and we're going to check and see if the health, so we'll just do this, duplicate this one right here. We're going to check and see if the health is greater than 0. So after it takes damage, we're going to say, hey, is the health greater than 0? If it is, well then we'll just go right back into combat mode. If it's not, then it needs to die. So let's say health check. This is yellow. And then we're going to set the dead variable to true so that we can control what's taking place on our character. We don't want it moving around or doing any more kinds of attacks whenever it's dead. So remember, we had all those dead checks. Set dead, and I'm gonna leave that black just because I want to, because it's death, it's morbid. Okay, so now we need a hurt as it comes in and does the hurt. Actually, I don't think you need. Do you need the hurt? I don't think you need one of those animation events. I think we can delete the hurt, and we just need the hurt end. So let's take this one out. We don't need hurt. We need hurt end. Right, so now it's over. So going back to our hurt state, let's say, okay, now the hurt end animation event, named animation event, the hurt end animation event has played, and now we're going to run that to a branch. Sometimes I get ahead of myself here. Now we're going to check the graph variable. Set graph variable, and we're going to create a new graph variable called dead. And actually, I think this one is going to be a graph variable as well. It is. Okay, so the The reason why we're doing that is because we need this to not happen inside the graph here. Okay, so this is going to be a private graph variable. We'll make one called dead, and we'll set that to Boolean. Okay, so we're going to set the dead variable. I'm sorry, we're going to get that variable. Is it dead? So this is a graph variable, get dead here. Skeleton dead. Again, the reason why we're doing this is because we only want this to trigger if it is dead. And skeleton, skeleton. There we go. We only want this to trigger if the skeleton is in the dead state. So if it's dead, then we want to trigger the death. If it's not dead, well, then we want to go back to the combat mode. So trigger custom event, and we're going to say go to dead state or death state. Man, if I could spell, it'd be great. Okay, and then right here we're going to duplicate that and then go call one hurt to combat, and this is just going to be transitions back from hurt to combat or from hurt to death. So these are our triggers. Trigger death, and that's going to be green. And then this one is going to be trigger combat state, and that is going to be green as well. Okay, so now we have our hurt state set up, so we can hurt the player. Sorry, we can hurt the enemy. Should be able to hurt him back now that whenever he enters into the hurt state, it is going to hurt the skeleton. There is actually one more thing I got to set up real quick because I forgot about it, and that is the hurt state. So what we need to make sure is that if the damage is taking place on the skeleton, remember we have a event called damage, custom event damage from the player to whatever enemy we're attacking. So this is going to be damage. So from non-combat to hurt, again on our player game object as we attack, it's going to let me see here if I can find the combat mode. As we look at attack, ground attack, it should trigger a custom event called damage right there. So it's gonna get anything that's in the circle and it's gonna attack that. So we're gonna use that to trigger a damage state for our skeleton, and this is in combat and in non-combat custom event. So we're gonna do damage here, saying hey, trigger that damage. And just ignore these errors. They're stupid. Anyway, then we need one more. We need hurt to combat. So custom event, hurt to combat. Okay, and that should send us back into combat mode. And we need one more here, custom event, and this one is death. So now that we have all of that set up, we should be able to hurt the skeleton now, and it actually shows us all of the animations and whatnot. So let's go ahead and try that out. Okay, you can hit me. Can I hit you? Oh, yes, I can. Oh, and you're going to go back? Oh, okay, we'll just trade hits until somebody's dead. Okay, so now it's in dead state as we look here under our flow graph of our skeleton. Let me see here. Here you see, it's in dead state, but right now we don't have anything in dead state happening, so we need to go ahead and set that up next. Okay, so let's go into that skeleton game object and go to the death animation. And here we are in the death animation. So what we need is whenever it reaches the end of the death state to say, hey, I'm done with my death animation. So let's set up a new animation event, trigger animation event, and call it death end. All right, so we're at the end of the animation state. So now let's go into our dead animation here, and we are actually going to delete the update and the on exit state. We're just going to need the on enter state. So as we come on into the on enter state, of course, we're going to play death animation. What am I doing? Animator play, state name, death is the name of that animation, I think. Yeah, death. Okay, so we're going to play that in the animator. So play animation. And there we go. Okay, so we can actually set that right there. And I think on my forum I have it actually backwards from this, but that's not a big deal. So now we're going to set the dead object variable to true, because we don't want anything else happening once this enemy is dead. So let's set that to a Boolean of true, and that is going to take care of all of the other stuff that it might be trying to move, like move the player or move the skeleton around while the player is still going. So set dead to true, and I'm gonna leave that black. Nah, we'll make it green. Whatever, make it green. And now we need to start a death sequence. So at the end of the skeleton animation, we had a animation event called dead. Animation event, named animation event, and it's called death end. That's where we put that. Okay, so now we're going to start kind of like a death sequence. Now this is very similar to a lot of other stuff that I've done before. We're just going to have the skeleton blink. So I'm going to go ahead and set up a sequence. What a sequence does is it basically triggers all this stuff at once. And we want to start it to where the first thing we're going to do is we're going to set the velocity to 0. So if the skeleton is moving or if it's falling or whatever, we want to set the velocity to 0. We also want to set the gravity scale to 0, and the reason why we want to do that is because we're going to disable the capsule collider 2D, so set gravity scale to 0, and we don't want it falling through the floor, because now you're not going to be able to, as you do this next part, the set capsule collider 2D set. Where's it at? Set enabled. It's capsule collider 2D set enabled. We don't need just the regular capsule collider. We need that one right there. So we're going to set that to false so that the player can actually move through what was the skeleton. Now it's just the skeleton body. We want to be able to walk over that. Then what we're going to do is we're going to set the game object to destroy itself. Game object destroy, but we need a timer to do so. So you have the object and then you have the time that it's going to do that. So we're just going to hard code that. Set. So we're gonna. What are we gonna destroy? We're gonna destroy ourselves. This game object, and we're gonna do that after, let's say, 2 seconds. So this is kind of the death sequence that we want to take place. All the stuff that needs to happen when this game object dies. So this is death sequence, just like that. And what we're gonna do now is we're going to use a wait node. So we're gonna wait 4 seconds. We're going to wait for 1 second, and anytime you use any kind of wait, and it doesn't work with timers, but anytime you use a wait, what you need is a coroutine. So clicking on your event here, every single event in Bolt has this option. So we're going to set the sequence, or sorry, set this animation event to be a coroutine, and you see these 2 little arrows come up right here. So now we're able to wait for 1 second, and then what we're going to do is we're going to trigger an event we're just about to set up. So trigger custom event, we're going to say death. We're going to trigger this death, and we'll add this unit custom event, and this one also is going to be a coroutine. So death. All right, we're going to trigger that one. Now just out of curiosity, do I have this is set to death. Why don't we rename that just so it's not confusing? We'll just try death blink. Let's set that to death blink, because that's what this is going to start doing. So what we're going to do here is every 1/10 of a second we want it to play like to look like it's blinking. And so what we're going to do is we're going to set the sprite renderer on and off consecutively until it's dead. So let's do an add set sprite I think it's Sprite renderer set enabled. There we go. We need that one. We need to turn it off. And then we're going to wait 0.1 seconds. And then we're going to set it right back on. Set it back to on. And then when we're done with that, we're going to go back into, we're going to do the same thing that we did here. Let's just duplicate this one. And we're going to continue doing that. So what that is going to do is it's going to say, okay, set the sprite renderer off, and so it's going to disappear, and then it's going to come back on, and it's going to disappear, and it's going to come back on, because it's just going to sit there and loop this thing until the game object destroys itself after 2 seconds. So it's going to sit there for a second, and then it's going to wait. Let's do a blink delay, and then after it is waited a second, it's going to start all of this blink event here. So let's do this blink effect loop. Okay, again, all of that is kind of like the death sequence. So we're going to play the death animation, and whenever it reaches the end of the animation, then it'll start this little sequence. Now we have a couple more things that we need to set up, and then we should be just about good to go with a fully functional character. We just need to set up the block. Okay, now when you test, you should notice that we are able to not only get hit by the skeleton, we can hit him back, and it will go into a death sequence whenever we get his health down to 0. So you should see him, he drops down to the ground, waits 1 second, and then it destroys itself after it blinks. So you don't see it in the hierarchy here anymore. So that is all working correctly, but let's go ahead and set up the block ability, because we want it to have just a little bit of strategy required to kill this game object. So for the skeleton, let's go ahead and set the block up, but you know what, let's do this real quick. Let's go to the skeleton shield animation, and let's go ahead and set up 2 events. So we have them right here. Let's go ahead and set one right there, and we're going to call this let's trigger animation event. Let's call this block, and right at the end here we're going to need one more, and let's call that one block end. And the reason we're doing that is because we want to play kind of like a special effect whenever it actually blocks. Let's name that one block end. And we also need to know whenever the animation is over. So going into our state graph now, let's go ahead and open up the block, and we're going to delete these bottom 2. We shouldn't need those 2. What we're going to do now is we're going to set up kind of like a pushback, because we not only want it to block, we want it to kind of push the player back a little bit. First thing we're going to need to do obviously is set the shield animation to play. So let's go to our animator play, and I'm going to do a state name. Oops, animator play state name. There we go. And let's go ahead, shield I before E, I think that's right. And let's say play animation. And you know me well enough by now that you know I'm going to set that to purple. And now what we need to do is we need to push the player back from this game object. So what we're going to do is we're going to do a player X position. Player X positions, because we need to know whether we're going to push this back to the left or back to the right. So if the player is to the left, we need to push him backwards. If he's to the right, we need to push him back to the right. So what we're going to do that is we're going to run the left over here, and let's do a rigid body 2D add force. And you need the second one here, the force and mode. And under the mode, we're going to select impulse. Now if you set it to force, you're probably not going to see very much at all, because the force has to be a high number and impulse can be something rather low. And I think actually we have our pushback set to 3, so that's what we're going to do. You're going to need to create vector 2 here. We're just going to send this into the X. So let's go ahead and grab our pushback object variable, and what we need to do for the left is we need to multiply that by a -1. So let's multiply. I think you can use a scalar here and just do -1, and let's run that into that right there. And then obviously this is going to be on the player game object. So let's do get application variable, and this is going to be player. Otherwise it's going to push the skeleton back. We want to push the player back. So this right here is going to be push back left, And then we can just go ahead and duplicate this. So duplicate that selection. And we actually don't need this node right here. We can just run the pushback into the X for the right, because it's always going to be positive. So pushback right. And I am going to rearrange this stuff just a little bit. There we go. And that's going to come right there. So now we have a pushback right, and we have a pushback to the left. So anytime the player hits and we enter the shield state, it will push the player back. Okay, going back to our skeleton game object, under that animation where it is actually using its shield to block, right there we want it to play some kind of particle effect or animation to show that we are actually blocking. And what I've actually done is I have created a kind of like a particle effect. It's really frame animation, but it's called Explosion, and I'll put that in the link below. You can get that also on that the Patreon page as you go into that online tutorial blog. It is located under the block effects, and it's called Explosion 47 by 56. And the reason I put that little number in there is so that you know exactly how you're going to need to slice this game object up. I made a new folder for my sprite there, so sprites, enemy, effects, explosion 4756. This is the information that I set on the inspector. I set the sprite mode to multiple, pixels per unit to 75, point no filter. This is going to make it look crisp and clean instead of blurry, and the compression is set to none. Go ahead and hit apply, and under our sprite editor we're going to slice this sprite up using those the cell size that I gave you. So 47 by 56 is what you're going to use here. So 47 by 56, go ahead and hit slice, and you should see that it slices this up just like that. Go ahead and hit apply, and now you should have an explosion here. And what we're actually going to do is we're going to create a new game object. So just grab all of those together and then drag them onto your scene and then let go, and it's going to set up a new animator controller. So we don't want to put that under our sprites. Let's put it under animation, enemy, and we'll create a new folder. Come on, new folder called effects, and then we'll go into there, and then we'll just say explosion, or yeah, let's do explosion. All right. So now that has its own animation, and that is what it's going to look like right there. So we do need to go ahead and set up in the animator here. We don't need that to loop. We need that to be loop time off. And under the animation itself, we need to know when that is over, because we have to have that game object do something whenever it's over. We need it to destroy itself. So let's go ahead and add an animation event here. Now you'll notice, like I told you, if it does not have a flow machine on it, you cannot actually select anything. So this game object, we're just going to rename to explosion. We're going to have to add a anytime you try to play something, it's going to turn the animation off when it's supposed to go off. So that's why that little check mark wasn't going. We're going to add a flow machine to this, and we're just going to set the source to embed, because it's just going to be on this game object. Now when you notice the animation event, you should be able to select now something from that. So trigger animation event, and what are we going to call that? Let me think. Actually, I think if we just do block end or end, let's just do end. Let's do end here, and now as we go into the flow graph for this game object, anytime there's an animation event, named animation event, and we'll just do end. Whenever this is over, we need it to destroy game object, or game object destroy. Yeah, that's what it wanted. And we can just do the object here, because it does not need to be a timer, and we're just going to do ourself. So whenever this plays all the way through, we need it to destroy itself. Now that is actually almost completely set up. We need to do one more thing, and I would add a new sorting layer here on top of the player, and let's just call this effects. So this is always going to render in front of the player, and then we're going to go back to that explosion game object, and we're going to set that to a, whoops, goodness, I am clicky today. All right, so I'm going to set that to an effects. So if we come right, let's see right here, you should notice that this is now going to render in front of the player, in front of everything. So it's just a way to get that effect to work correctly. So now what we're going to do is we're going to go to our player controller, we're going to go to our prefabs folder, and I'm just going to grab that explosion and then I'm going to drop it right there. So now I can delete this from the hierarchy, and anytime we want to use this or call this, whoops, that's a player ghost, not the right one, right here, we should see that playing the way that it's supposed to. I think we set that to, yeah, we turn the loop time off. So that is ready to go and good to go now. So now we go into the block phase, and we need it to actually play that little animation event. The way we're going to do that is we had it set up under a named animation event, and I think we said block. So whenever we block on that skeleton game object under the shield animation, whenever we get to right here, it's going to play that string there, and we need to say, okay, whenever that happens, we're going to first check the direction. So branch, we're going to check the sprite renderer, flip X, get flip X, and this is going to determine whether we're facing the left or facing the right. So get direction, and right there, okay. And now that we have our direction, we need to determine whether it's going to play on our skeleton game object to the left or to the right. Now, a good way to set this is if you actually look, we have block left and block right there. We can go ahead and set that to play on one of those two game objects. So if it is true, if flip X is true, it means it's going to the left. We're going to instantiate a game object. Game object instantiate. Okay, and we need the original position rotation. So what are we going to instantiate? Well, we are actually going to instantiate that block. So or explosion. This explosion. There we go. We had it under explosion. So we're going to set that to instantiate. And where are we going to do that? We're going to get the position of that child game object number. This is to the left. We need number 3 because that's the 4th one in the list. So get child, and we need number 4, which is 3 in the list. Okay, and then last thing we need here is we just need to set this rotation. I don't know why it's not just default. It just seems like it would make more sense if they, under this game object instantiate, if they had it just set to 0, 0, 0, 0 at all times. But, you know, you need that little node. It's just the way they have it set up. So this is going to trigger the block effect left. Oops. Let me fix that. Lowercase e. There we go. And this is going to be green. And now we're going to duplicate this whole thing. Ah, come on. We're going to grab all of this and duplicate it. And we're going to tell it to go to the right. The way we do that, you guessed it, is we're just going to change this from 3 to 2. That now it will instantiate that on the 3rd game object instead of the 4th one. Okay, so now false is going to go here, and that will now trigger that whenever we block. There are a couple of things that we need to set up. First of all, let's go into, as we come back into our skeleton super state here, let's go from hurt to block. So we're going to do a custom event, and we are going to say, okay, we're going to do a block here. So anytime we trigger that custom event block, we're going to come back to that, and block to combat, I think, is what we need to set up here. So custom event block to combat, and that is going to say we're going to go back to combat mode from our block state. Okay, and then we obviously need to set that up as well. So we need to, under our block state, we need to say, let's just come over here. It's going to say named animation event. We're going to say block end. This is that animation event we had at the very end of the shield animation. Block end, and this is going to go trigger custom event, and we're going to set up a block to combat. That's going to trigger that back from block state to now our combat state. So transition, goodness, transition to combat. Okay, the next thing we're going to need to do is we're going to have to say if block is active, we don't need it to play the hurt animation. We need it to go to the block, which is what this little transition right here needs to do. So we're going to go into our hurt state here, and before we ever play that animation, let's go over here to on enter state. Let's break that line, and we're going to run this into a block check. So let's go to a branch, and let's say is block true. Block. So we're going to get the block variable. If block is true, then we need it to go to block. If it's not true, well, then we can come back in here to the hurt. So let's go right there for hurt. So we're going to block check. Block check. This is going to be yellow. And then if this is true, then we're going to come back in here to set a block custom event. So trigger custom event. We're saying transition to block instead. Okay, so we're going to trigger the block. Okay, and that is set up. Now we should see that when we test, it will play the block animation, but there's actually going to be a little problem that we're going to have here, and you probably should see what it is. It's probably easy to tell. We'll check that out now as we are entering play mode. We will not be able to hit the skeleton, first and foremost. It will block, but if you notice, that block animation is not in the right spot. It's never hurting the enemy, and so no matter what we do, we can't hit him. But if you actually look, it's to the right there, and it needs to be scooted over just a little bit. Now, you might be tempted to think, well, the problem is where we're putting the block. But the actual problem is, if you look at the skeleton animation, so let's go to that shield. If you look, the pivot point on our game object is right here. We need it to be over here. So what happened? How do we fix this? Well, the way that we fix that is going into that skeleton animation. So let me open up the sprites, go to enemy, whoops, player controller, sprites, enemy, skeleton, and we're going to go look at that shield animation. And what we're going to do here is we're going to open up the sprite editor, and we're going to adjust the pivot point on that just a little bit. So let's go to the sprite editor here, and what we need is it to scoot over to the right just a little bit. We actually need it right about there or somewhere in there. So if you notice here, it's at a 0.59 and a 0.5. So we could go ahead and individually set all of these to a 0.6 here on the X, but let's just reslice it. What we're going to do is go right here on our pivot, we're going to do custom, and then on the X it's going to be a 0.6, and on the Y it's going to be a 0.5. So as you go ahead and slice that, you should notice, whoops, I think I had it, yeah, you got to set it to cell size. This is a 150 by 150. Now when we set it, it should set it correctly. There we go. All right, so you notice the pivot point has scooted over to now it's in the center of the skeleton and all those places. Go ahead and hit apply, and now when we attack, we should notice that the skeleton, that the block will happen kind of more on the shield instead of in the middle of the body. You notice there, see it's blocking, and the player is not getting pushed back, so we're going to have to adjust that as well. Okay, the reason why it wasn't pushing the player back is because that mass was set to 100. So if you want the player to be set to 100, you're going to have to take the skeleton pushback and you're going to have to increase it 100-fold. So right now we have it set to 3. Let's set that to 300, and let's see if that fixes our problem. That whenever the player attacks, it should push him back quite a bit. So let's try that. Boom. So all right, there you go. So you notice it's pushing him back now. We're not able to hit the skeleton. The skeleton is still able to hit us. So we need to fix it to where the skeleton has kind of like a little bit of vulnerability time in its attack. To add that vulnerability time into our enemy, what we're going to have to do is every time it attacks, it needs to set that vulnerability active. So what we're going to do is going into our skeleton combat attack super state. Let's go into attack 1 left, and we'll work with that one first. At the end of this attack here where it says attack L trigger, we're going to run in a new set vulner time object variable, and what we're going to do is we're going to set that to the current game time. So we're going to get time, and this is a way to establish a cooldown. So we're going to set the vulner time here. So set vulnerability time. Make that green. We're going to set it to the current game time so that we can check that in our state handler. So we're going to take that and we're going to now set object variable block to false. And Boolean block to false. Okay, so set block to false. So after it swings for the vulnerable time, it now becomes vulnerable, and it also is on that cooldown. So we're going to set that in our state handler in just a second. So set this to inactive, and now we're going to set that to red. So we're setting the block inactive. Now copy this little thing right here, and under each one of these we need to go in and say every time it attacks, no matter which way it attacks, we need it to do this. So just copy and paste it into all 4 of these. And remember, you do need all 4 of these because it's attacking with which attack it's attacking and the direction. So there we go, attack, there we go. All right, so the last one is right there. Okay, we also want this to reset anytime the enemy gets hurt. So going into our skeleton hurt state, we're going to actually go right here after it triggers the combat. We're going to take this and we're going to scoot this over just a little bit, and we're going to break that line. And now we're going to set vulner time. So this is going to reset that vulnerability cooldown, get time to whatever the game time is. And then I'll show you how to set this up. So this is going to go right here, and then that's going to go right here, and we're going to call that set vulnerability time. And this is green. This is going to be scooted back over right there just to make it nice and clean. Okay, and the last change we need to make is inside our state handler, we need to add that block cooldown function. So the way we're going to do that is we're going to make one more update node here. So go to update, and then we're going to run that into a branch to check if block is ever false. So block, get the block variable, which remember we do that every time we swing or the enemy swings or it gets hit. It's going to set that block inactive, and it is going to increase the vulnerability time. So block check is set to that right there. And now what we're going to do, anytime block is inactive, we are going to do like a cooldown check here. So branch. So, and the way we're going to do that is we're going to see if the vulner time, the game time minus the vulnerability time is greater or less than the vulnerability cooldown that we have. So we have that window set. So less or equal is the node we need. And let's go ahead and get the time. So get time. And subtract, just the generic one will work. We're going to subtract the vulnerability time, get vulner time. So remember, we set the game time to the current vulnerability time, and the time is always going to be moving forward. So wherever we set that, we're going to check the current game time minus the wherever it swang, it soared, or it got hit. We're going to subtract the game time from whatever the vulnerability time currently is, and we're going to determine if this is less or equal than the vulnerability time. Vulnerability time. Sorry, the vulnerability cooldown is what we need, not the vulner time. So where is my vulnerability cooldown? Did I miss that one? Okay, well, let's go add it real quick. We've got to go to our skeleton game object and add vulner CD. You should already have this one, but if you don't, just go ahead and add it right here. And I think we set that to 1 second, if I remember correctly. And what that is going to do is it's going to allow us to have a 1 second window of vulnerability before it goes back in and it sets that that block to true. So if this is never less than the vulnerability cooldown, we're going to set the block cooldown to true. Hopefully you understand what that's doing. It's just checking if the vulnerability time that we set is less than the vulnerability cooldown. So set block active, and then we're going to set that green here, and this is our block cooldown check. All right, so vulnerability time. So is the time up is essentially what it's asking. And we're gonna set all this to a block cooldown. Okay, now when you test, you should notice that it is actually active to where you can not only block with the skeleton after it swings, or if it gets hurt, it should reset that cooldown. So there I'm not able to attack the player, or sorry, the player is not able to attack the enemy, but when he swings, it now is vulnerable and I can kill it. Okay, that is it for the melee portion of this build. Again, if you'd like to move to the projectile firing enemy or the flying enemy, you can certainly do that by becoming one of my supporters on Patreon. Once again, I'm only going to be addressing questions for this build on my private Discord server that is available to all my patrons. If for no other reason you'd like to become a Patreon supporter than to just see more tutorial content like this one, I would really appreciate it. Just completing this one online tutorial blog took me about 60 hours to complete, not counting the initial build or the video tutorial. So as you can imagine, doing a tutorial like this one is a lot of work, and if you enjoyed this tutorial, I'd really appreciate your support. That being said, I hope this was helpful for you and that you learned something. As always, thank you for joining me. My name is Megahertz, and I'm out.